Okay guys, I'm using a different program. I'm not on here as far as my face, but you should still be able to hear me, hopefully. What I want to do is really get straight into how to graph, and then we move on from there. All this information you had on the last video is good to know, this type of information. What I'd like to really get into though is the graphing aspect of how this thing works. So let's take a moment to look at that. Alright, I want to graph this right here. I want to graph this particular function, and I just want you guys to know that whenever you have to graph, what I'm about to show you always holds true. This first step, you can always do this. Don't forget this. You can always make a table. X is independent, Y is dependent, meaning X can be whatever you want it to be. Y, you have to depend on whatever X is. And I always like to pick numbers like 0, 1, -1, -2, numbers like that. Sometimes depending on where your graph is, those may not work or may be too big, but always try. If you have a hard time, you can always make a table of graphs. So let's do that real quick. If I put 0 in for X, right here, that'll be 0. 3 times 0 is 0. So the Y would equal 0. What about if I put 1 in for X? Well, 1 times 1 is 1. 3 times 1 is 3. What about if I put -1 in for X? Now, I'm going to write this one down because that'll be Y equals 3 times -1. Notice how I put that in parentheses. That's -1 times -1, which is +1. So Y also equals 3. What about if I put 2 in for X? What about if I put 2 in for X? Well, in that case, you'll have Y equals 3 times 2 squared. 3 times, wrong, 2 squared is 4, and 4 times 3 is 12, so Y equals 12. Let me ask you this, what do you think I'm going to get when I put 2 in there? Based on what you see up here, I should get the same thing, positive 12. Now that should be enough for us to go graph those points right there. And so let's do that. Let's graph those points. Okay, so I'm going to graph 0, 0, 1, 3, -1, 3. Oops, that's not 3, is it? Nope. 2, 12, and -2. 12 is right there. Now we can see that this is our parabola right there. Kind of ugly drawing, but that's our parabola. Alright, now that's the basic elementary way to do it. But let's find our vertex. Let's find all those other pieces so we can actually learn how to find those and then graph from those. Okay, still on this same example here. Alright, so what I want to do is find my vertex. Alright, but before I find my vertex, it's easier just to find the axis of symmetry. Now, why do I want to find that? Because the axis of symmetry uses this equation, x equals -b over 2a. Alright, so the axis of symmetry, if I use that, I'll have x equals -b, there is no b, so that's 0 over 2 times 3, which equals 0. Alright, so x equals 0 is my axis of symmetry. Alright, what about the vertex? If you want to know the vertex, you take your x and put it in for the x coordinate there. Now in order to find the y, we take x and substitute it in for x here. So when we do that, we get y equals 3x squared, which is simply just 0, because that's just 0, and then 3 times 0 is 0. So our vertex is 0, 0. Okay? All this stuff we just showed you on the graph. Now, which way does this thing open? Since this number is positive, the number in front of the x squared, which is a, since a is positive, it opens up. Alright? Excuse me. What about the x-intercepts? Where does it cross the x-axis? We already saw that in the graph, but that's when you put 0 in for y, and then you solve by factoring or completing the square or square roots. And if I divide this by 3, I'll get 0 equals x squared. And how do we get rid of the 2? We take the square root of both sides. So that's just x equals 0 again. It's not plus or minus because 0 is neither positive or negative. Alright, so we really only have one intercept, and that's the point 0, 0 there. Okay, so all this information is very important. Now, let's talk about real quick a maximum or a minimum. Because what that means is if it opens up, your vertex has to be a minimum. Now let's explain all this as we go back to our picture, our graph. You see how the vertex is the only point on the x-axis? So that makes sense that we only have one x-intercept, and it's at 0. Alright? You see how it opens up? This also is the lowest point, so that means it's the minimum. Alright? The axis of symmetry is x equals 0, which is this line right here, because this is where x is 0. This is x equals 1, x equals 2, x equals 3, x equals -1, -2, -3. And so this line right here is x equals 0. And so basically what I just did was I graphed this equation, y equals 3x squared, by using a table first. Yes, you can always fall back on that. Don't ever get something wrong by graphing. But this is the stuff that you need to know how to find. All this stuff here that I have to test you over. Alright, let's keep moving on. Excuse me, I got something in my throat. Alright, let's keep moving on to alrighty, this example here. Y equals x squared minus 2x minus 1. Alright. Alright. Now, again, if we want to, we can always use a table. If x is 0, I put 0 there, and 0 there, I get -1. If x is 1, I put 1 there, and a 1 there, and that's 1 minus 2 minus 1. So what's 1 minus 2 minus 1? That's -2. Now, I'll put -1 there. Now see, this one is not like that last one where we can just simply say, oh, it's just going to be the same thing over and over and over. I know that it only applies in certain problems. So don't always try to do like what we did on this particular problem where it's just going to be the same thing. That only happened because we only had this. We didn't have anything else added or subtracted to this equation, okay? See, this one is a little different. We got some more things added to it. So you can't just say, oh, that's going to be -2 now just because that one was 1. So don't fall into that trap. Hopefully y'all paid attention to what I just said. Y equals -1 squared minus 2 times -1 minus 1. So that's going to be 1 plus 2 minus 1, which equals 2. See, it's not the same thing here. And so that just gives us an idea excuse me, of what the line is going to look like. So if we plot those points, 0 on the same graph, I'm going to do in a different color so you can tell I'm doing a different graph. I'm doing the point excuse me, 0, negative 1. So that's your vertex right there. And 1, negative 2 over 1 down negative 2. And negative 1, positive 2. Okay. So basically, you can kind of see we only got like half of it. We only got like this side, the left-hand side of a parabola. But that's okay. We kind of got an idea of what it looks like. We'll come back to that. What I want to do is go to this problem and work it out the way that I showed you before. I'm not going to show you this table anymore because we need to be able to find the vertex and all that good stuff. So let's start off with the axis of symmetry. And that's going to be x equals negative b over 2 times 1. Now I'm using that formula that I showed you in the notes for the axis of symmetry, which is x equals negative b over 2 times a. Remember, a, b, and c comes from this right here. Alright, so now this simplifies to 2 over 2, which equals 1. Now whenever you find that your axis of symmetry is x equals 1, what you've also found is that your vertex, the x coordinate, is already found because it's always going to be the same thing. Now the way that we find our y's, we take 1 and we substitute it back into that equation for and it just so happens that we actually already found that y is negative 2. So we found our vertex already. Alright? Now, which way does this open? A is positive, so it opens up. That's just good to know. Alright, so when we're graphing, we can understand what we're trying to find. What about the x-intercepts or the zeros? Remember, those are the same things. X-intercepts, zeros, or roots, they're all talking about the same thing. So what that means is we take our problem, our original problem, and we substitute 0 in for y, and we get this. And it doesn't matter where it is. You can flip it around if that bothers you. And so what I'm going to do is try to solve this. Now you can solve by factoring, completing a square, or quadratic formula. It doesn't matter here. I don't care. I would try to factor, but I know it doesn't factor already. So what I'm going to do is take x squared minus 2x minus 1, and I'm going to add 1 to both sides. What am I doing? I am going to do completing the square, where I take 2 divided by 2 and I square it. So I take 1 and I add it to both sides, and so this factors into x minus 1 quantity squared, and that equals 2. What am I doing? I am solving the quadratic equation, because this is how you find the x-intercepts, the zeros, or the roots, all the same thing. Remember, when you get to this step, you take the square root of both sides. X minus 1 drops out, and you got plus or minus 2. And so in order to solve, you add 1 to both sides, and x equals, oops, forgot the square root thing, 1 plus or minus the square root of 2. Now remember, what that really means is x equals 1 plus the square root of 2, and x equals 1 minus the square root of 2. So that right there is the same thing as both of those. Alright? Now, why did I go ahead and do that? In this particular instance, it's important to do that because we need to graph this. And so when you put this in your calculator, this is that means approximate. This approximately equals 2.4, and this approximately equals negative 0.4. Alright? Now, just to let you know, when you put this in your calculator, it'll turn around and give you this. But then I have to hit this little button that makes that, which is this button right here. And when you hit that button, it'll give you the decimal. Alright? So, just letting you know, when you first put it in the calculator, it'll switch it around on you. But that's alright. Just hit the button on top of enter, this button right here, and then it'll go ahead and change it to the decimal. So now, if I really wanted to, I can say, well, that's 2.4 comma 0. That's an x-intercept. And 0.4, negative 0.4 comma 0. All right? That's my x-intercepts, and I found all this other stuff. So I go back to my graph. All right, looking at my graph, I found out that my vertex is 1, negative 2, which is this right here. Which means my axis of symmetry is this line right here. And again, it's dotted or dashed because it's not a real line. It just lets you know that things are symmetrical on that line. Just kind of ignore this other one. I'm just only focused on the blue one right here. We know it opens up. And then we found our zeros, which are 2.4. So that's positive 2.4. So that's 1, 2. And 0.4 is almost halfway. Like 0.5 is halfway. So I'm going to do that. And then negative 0.4, which is almost like a negative half. So we're about right there. And one final thing I'd like to show you before we finish, and I'll go ahead and graph this. Let's talk about one other thing, and that's called the y-intercept. The y-intercept is when you put 0 in for x. And the shortcut for that is that all you have to do is always say your y-intercept will be 0c. Whatever c is, if it's written like this, that's going to be your y-intercept. If this is standard form, remember what your note said, this is standard form. If it's ever written like that, then you just write your y-intercept as 0c. Or if you can't remember that, you put 0 in for x. So you put 0 squared minus 2 times 0 minus 1, and of course you get y equals negative 1. So our y-intercept is 0, negative 1. Now, we actually already have that on our paper, 0, negative 1. But why is that important? Why did I want to put that on there? Why did I want to talk about this right here as my y-intercept? Because again, this is a symmetrical graph. So if I have a point up 1 and to the left 1 from the origin, from the vertex on this side, then it goes also that there's got to be one symmetrically right there. And the same thing goes for this point here. The whole thing is symmetrical. So now I have a really good idea of what this looks like. So I can go ahead and don't make a V, kind of round it off. And that is your ugly looking parabola because I can't draw. Alright, let's try one more. And one more is going to come from number 2 here in the notes. Okay, let's talk about graphing this one. And again, I'm not going to use the table on this one. Keep in mind this right here. This right here is basically saying that whenever you have an equation written like this, it's called vertex form. And vertex form basically says, I'll tell you the vertex. That's why they call it the vertex form. Vertex is basically the number here and the number here. The number here, whenever you pull it out, you got to change its sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. However, the number out here stays the same. And so looking at this particular example, if I said, what's the vertex? You ought to automatically be able to say the vertex is 1, comma 2. You change the sign of this number, and you keep that number the same. All right? So then we're going to move on to the rest of trying to solve that. So I just want you to know that that's vertex form. It's sitting right here. The axis of symmetry is x equals h. It's already telling you some things, right there. Let's go ahead and work it, though. I said work it, though. All right, there you go. So our vertex, we already found. Just talked about it. Our vertex is 1, comma 2. You don't change that sign. It stays the same. That's your y. That's your H, actually. You change the sign of that, which means the axis of symmetry is also x equals 1 because those two are always going to be the same. It opens up because A is still a number in front of here. A is positive. And so since A is positive, or you don't see a negative sign, we know that that opens up. What about the x-intercepts? Oops, intercepts. All right. So the x-intercepts come from putting 0 in for y, and then solving for x. Okay, so how do we do this? This almost looks like completing a square. So you subtract 2 from both sides. X minus 1 squared. But how do we get rid of that squared thing? Okay, well, take the square root of both sides. But we get x minus 1 equals the plus or minus the square root of negative 2. And now I have to stop because we haven't talked about imaginary numbers. You get an imaginary number whenever you get a negative number underneath the radical. I'll go ahead and finish it, but I'm going to go ahead and put the x right here. 1 plus or minus the square root of negative 2. As far as we know, that's as far as we can go up to this point. Now, if I'm playing this for a class and we've already talked about how to do imaginary numbers, you got to keep going. But the whole idea is, if it's imaginary, it's not real. And our graph is, excuse me, on the real number line. All these are real numbers. And so I won't be able to graph this because it's imaginary. That means it doesn't cross the x-axis. So I don't have any x-intercepts, okay? There aren't any x-intercepts. So let me find my y-intercept, because that's going to be very important for me to get a good idea how this graphs. Now, whenever you find the y-intercept, remember I said earlier, you put 0 in for 1. And so when you do, what you're going to get is negative 1 times negative 1, which is 1, plus 2, which is 3. So my y-intercept is actually 0, 3. All right. So let's go back to this one using the same graph all over again, using a different one. 0, 3 is this point right here. 0, 3. All right. Hopefully y'all can see that. Yeah, I'm using one graph over and over and over again. No, that was the y-intercept, excuse me. The vertex is 1 over 1 up to 1, 2, and I didn't even put that at 0, 3. Lord have mercy. So forget that. This point doesn't really exist. Sorry. The y-intercept is actually 0, 3. The axis of symmetry is this same line, actually. It turns out to be that same line. Forget that. That doesn't really exist. Since it's symmetrical, this point right here also exists. That's all really I have to show right now that that's what the graph looks like. Could I have made a table? Sure, I could have. But really knowing the y-intercept let me find that point, and knowing the vertex, I was able to get a good sketch of what the graph looks like. So in summary, in conclusion, to finish up these weird notes that I'm using on a different program, you can graph by using a table. But if you can find these items, if you can understand what's going on here, and again, that simply means whatever you find here for x, substitute it in here for x, and that's what this notation means. Notice it's the same thing. So that's how you find the vertex, using this formula here, which is also the axis of symmetry. You can tell how it opens, if it opens up or if it opens down. We can talk about the graphing calculator in class. Also need to know that the highest point of or the lowest point has a name, maximum or minimum. And it's very easy to figure out which one is which. It really depends on how it opens. And then finally, in order for you to find your x-intercepts, it's important for you to realize that your x-intercepts come from you solving a quadratic equation. And this is me using completing the square. We learned completing the square. We've learned quadratic formula. We've learned solving by factoring. Whichever one works. Me personally, I'm fond of factoring because it's easiest to me. However, this one didn't factor. This example here did not factor. So what I end up having to do is try something else. Could I use quadratic formula? Yes. A hint is that quadratic formula works all the time. And so if you ever just need to pick one, quadratic formula will work all the time. Completing the square sometimes act funny. It should work all the time too, but I haven't taught y'all all there is to know about completing the square yet. So at this time, quadratic formula will be the one that works any and every time. But me, I'm going to try factoring because it's so easy to find out if it's going to work or not. All right, guys. I hope these notes work, and I got to find something else that works for me. All right.